A few days back, accidentally our dry iron has stopped working. But you can see the indication light shows that the current has passed through on it. But no heat is produced. What an dry iron normally does. So today in this video of electronics basics, I am gonna show you how to repair dry irons and how this device works. So let's get started. To know how an iron works, let's take a functional one and just connect it to the wall power socket. After a couple of minutes, as obvious, I have realized that it's heated up quite a bit. So some kind of heater is used inside it. Here a question arises, what is a heater? Basically, the concept of heater is very simple. If I take a piece of wire and flow some current through it, the wire will become hot. Obviously, if the current flow through the wire is high enough. Very basic concept, right? But the problem is that a simple piece of wire has a very little amount of resistance. Normally we use copper in the wires. The resistivity of the copper is 1.68 into 10 to the power minus 8 ohm meter. So if I have a wire with the length of 1 meter and a diameter of 1 millimeter square, then according to the formula of R equals to rho into L by A, resistance is 0.016 ohm, which is almost negligible. Because of the low resistance, it can't produce the proper heat what we actually need in this situation. According to the formula of heat generation, H equals to C square RT. Here a new metal alloy is introduced called nichrome. It has very high resistivity than copper. 1.10 into 10 to the power minus 6 ohm meter. So in a length of 1 meter and a diameter of 1 millimeter square, the resistance of nichrome is 1.10 ohms. It's almost 68 times more resistive than copper. Now you know that when the same length and diameter of nichrome and copper wire are subjected to equal voltage, nichrome wire will heat more than the copper wire. So if I conclude everything, then the nichrome wire is used to produce the heat. So that if the wire is damaged or interrupted, then current can't flow through it. And obviously no heat will be produced. Keep this theory in mind. Let's disassemble my damaged dry iron. To open the enclosure for this particular model, of course, loose the screw from its back. Now you can see these are the main power lines. Positive, earthing and negative. After loosening these 3 screws, disconnect the power lines and coil connection. Now I have to loose these 2 screws for further tear down. Now very carefully lift the upper portion of the enclosure. To expose the internals, I have to unscrew these 3 screws of the plastic lid. After that, very carefully remove the neon lamp which is used as a power indicator. And yes, don't forget to remove one terminal of the neon lamp from here. Otherwise the plastic housing cannot be removed from its prison. That's it. This is the coil. Now you should have the query in your mind that where is the nichrome wire? The nichrome wire is inside the aluminium casing, aka the metal casing. To protect the nichrome wire from short circuit with the aluminium housing, a material called ceramic is used. Hope you guys previously noticed that this metal wire is broken. And as obvious, broken wire prevent the electricity flow inside the coil. To connect this portion to the power lines, I have taken 0.5 mm thick copper wire. Now I have to strip the wire to expose the copper. To make this wire solid, I have picked my solder iron and create a very thin layer of solder over the copper wire. Before using the soldering iron, I have rubbed a bit of soldering paste into it. Now again there is a little problem. I can't lose this screw with screwdrivers because it's damaged by the rust. To solve this problem, I have used a little bit of machine oil made by 50% kerosene and 50% of coconut oil. After half an hour, I can easily rotate this screw with my plier. Screwdriver is totally useless here because the screw heads are totally gone. Now I wanna replace these 2 screws with new one. After connecting the newly created wire with the new screw, the job is almost done. Now very carefully assemble the first part of the iron. Now set up the neon lamp with proper connection. As I told you, this lamp is used for the power indication. If you are interested, this regulator is an adjustable thermostat. When I set a desirable temperature aka mode like silk, wool or whatever this metal screw rotates. Because of this rotation, it presses the metal plate beneath it. This plate is responsible for everything what a thermostat can do. When this portion of the switch is moved upward, the electrical contact breaks. As much as the big screw rotates clockwise, the force will be more to move this portion. This force is provided by the bimetallic strip. When the temperature rises on the iron, it starts to bend upward and push this screw, aka this whole portion. When the iron is on a desirable temperature by adjusting the knob, then increased temperature can bend the bimetallic strip a little bit, and the electrical contact is disconnected. And the iron is started to cool down. When the temperature drops inside the iron, the bimetallic strip takes normal position. Now the electrical contact is joined and current can flow through the coil. This cycle is repeated again and again and again. Now you know how an electrical press or iron works. Let's assemble everything in place. Now the one thing is that this portion should enter through this metal portion. Otherwise, this regulator can't work properly. Now connect the power lines. Now tight this screw with the lead. That's it. The iron is now ready to use and heated up properly. The problem is solved. Now you know how an iron works. Hope you have liked and enjoyed this video. If so, then don't forget to like, share and subscribe, and please turn on the notification bell for future updates. Thank you so much.